Well, I bet you didn't expect to hear from me again so soon. Last week I spent all of my time doing that Photoshop image, so I really didn't have time to do any electronic work, if you want to put it like that. So what I'm going to do here is just show you the few other steps that I took with regard to trying to get this laptop working. So the first area of troubleshooting was this MOSFET here. As I've said in the previous video, I swapped out this MOSFET. When I did, it made no change to all the voltages around it, and the gate pin was still 17.9 volts. So the first thing I did was I connected the gate pin to ground. So I'm essentially giving the gate pin a voltage of 0 volts to ensure that it's on. But when I did that, it made no changes to the voltages around it, and the laptop still wouldn't power on. The second troubleshooting steps that I took were to look at the battery management IC. As you can see, I have moved the components around here on my schematic, and I have created enough room to put in the battery management IC. So first of all, I checked the AC detect pin, which had 2.6 volts on it, so that's good. I then checked the Reg N6V, which is 6 volts, so this is a sign that the battery management IC is working. And then we already knew that the BQ-AC drive, which turns on and off the second MOSFET, was already on 25.3 volts, so we already know that this signal is good. But it seems that all of the signals to the battery management IC are okay. And the third troubleshooting steps I took were to re-evaluate our PU11 and PU12. So as you remember, we are getting from P11 our 3.3 volts LDO, but at no stage have we got the switched output working. Similarly with PU12, we have the 5 volts LDO working, but at no stage have we got our switched output working. When I pull up the datasheet for PU11 and PU12, they're actually using a very similar IC. We see that there's an enable pin on pin 1. So what this says is pin 1, enable control, pull this high to turn on the IC, do not leave the pin floating. When I checked pin 1 of PU11, which is this pin here, and pin 1 of PU12, which is this one here, I found that it measured 0 volts. So I think that PU11 only requires an input voltage in order to produce the LDO 3.30 volts. However, to produce the higher current switched output, the enable pin needs to be high. Similarly, PU12 will produce our 5 volts LDO as long as it has input power. But to produce the higher current switched output on pin 10, it requires that pin 1 is high. So the question really is, what is it that provides the enable signal for these two ICs, and why is it 0 volts? Well, looking back at our schematic, I traced the path from the enable pins of those two ICs, and it actually goes back to our Super I/O. So it's pin 100, which is labeled as S5_on, that is supposed to provide the enable signal to switch the two of these ICs on. And the S5 is a reference to the power state, which S5 power state is shut down or off state. And I think what this means is that this signal should be being provided from the Super I/O even when the laptop is in a shutdown or off state. So why are we not getting an enable signal from the Super I/O? Is there something wrong with the Super I/O, or is the Super I/O detecting something that it is pulling that signal because it sees a fault somewhere else? Or is there something wrong with possibly these ICs here? So I thought it might be useful to provide my own enable signal and see if I could get those switched voltages to come online. How did I do that? Well, I jumpered from pin 5 of PU11 to pin 1. So that carries the 3.3 volt signal to pin 1, which is already connected to pin 1 of PU12. And with 3.3 volts jumpered to the enable pins of PU11 and PU12, both of their switched outputs came online. So I measured at pin 10 of PU11 and I found it was 3.3 volts. I measured at pin 10 of PU12 and I measured 5.09 volts. So it looks like both of these ICs are actually working. They're just not getting the correct enable signal. So why is my Super I/O refusing to provide a high signal on pin 100 to enable PU11 and PU12 to switch on? It could be that the Super I/O itself has a problem, or it could be that the Super I/O is detecting a problem somewhere else and just refusing to provide an enable signal to those two ICs. Now at this point, if I had another Super I/O, I would chance replacing it and see if that made any difference. But I don't have one of those ICs here, and I'm pretty sure it requires programming if I purchase one online, so that's not a great option either. So that's where I'm going to leave this little follow-up video. I'm sure that you're all sick to death of this laptop, as I am myself, but I'm conscious that I don't want my videos every week to be me just replacing a shorted capacitor and then I have my hero moment at the end where I reveal how I fixed the laptop. It's these laptops that are difficult that you actually learn stuff from. Plus, it's given me the exercise of trying out things with this schematic here. I think this schematic is going to be important to the channel going forward. I'm going to see if I can incorporate it on my next fix and just have like a bundle where I put up the video and then you can follow along on the copy of the schematic itself. So that's the plan. But that's all I got for this week, guys. It'll be next weekend before I post again. Please like and subscribe and post any further comments down below.